There are very few camera fire detection products on the market. Verifire is the only product that has 21 worldwide patents that invented the camera with built-in fire detection technologies. This video shows you the invention of the camera fire detection technologies, related to patent number 7868772, granted by USPTA on January 11, 2011, entitled Flame Detecting Method and Device. This patent invention improves the accuracy of flame detection and reduces the possibilities of the false fire alarms. This invention can be illustrated by this fire detection workflow. Verifire utilizes the fire detection patents via the programming logic. First of all, the basic unit of digital signal are 0 and 1. The video color representation is more complex. Video display to CRT are driven by red, green, and blue voltage signals. But these RGB signals are not efficient as a representation for storage and transmission, since they have a lot of redundancy. YCBCR color spaces are defined by a mathematical coordinate transformation from an associated RGB color space. YCBCR stores the video via a set of color values represented by luma signal and two chroma components. To determine if there is a possible fire, the Verifire program deploys the threshold technique, which has adjustable parameter values instead of hard-coded values to determine if it matches the pass or fail fire detection criteria. Verifire deploys artificial intelligence calculation, based on instances or events of fire detected, stored in the database to adjust the threshold for each step of the fire detection. This is the reason Verifire can actually accurately detect real fire more and minimize the false alarm. Let's explain it step by step. Step 1. Capture several images. The Verifire camera captures 10 frames per second when the size of most of the frames is 360 by 240 pixels. System store images for future comparison. Step 2. Detect moving objects from the captured images. Verifire compares captured images frame by frame to determine if the video has any change of video backgrounds. Verifire divides the video screen to 40 by 40 blocks of images to perform the comparison. If any of the 1600 blocks has image changed, then it will go to step 3. System keep the first frame as original background and gradually change. Every pixel represents by a set of 3 YCBCR values. If the value change greater than the threshold, then system consider the background has been changed and possibly it is a moving object. System maintain a set of ranges that control the YCBCR color value set. And our system use historical data to enhance the range control value set to improve the accuracy of flame detection method. Step 3. Color model analysis. This step is to match the characteristics of the flame color. Flame color also been represented by a predefined value. Verifire uses YCBCR color model which has a high level of accuracy in color analysis of the flame. Captured images will be extracted sequentially, analyzing and comparing each result if it reaches the reference threshold value of smoke and flame. If the color of the moving object is within the definition of red, yellow and white, then it depicts the color of the flame. Step 4. Flickering analysis. If it matches the characteristics of the flame color, then it will proceed to flickering analysis where color and height variations of the moving area will be analyzed. If the flame has the characteristic of a flame flicker, which means the brightness of the object fluctuates, and if the flickering frequency of the flame light belongs within the range of definition stored in the database, then it is consistent with the characteristics of the flame, then it will proceed to step 5. Step 5. Centroid and area variation analysis. If it is indeed a flame, its location should not be changed in a very short time. This step verifies whether the centroid location of the flame belongs to the same area. In addition, the area of the flame gets distorted or deformed over time, which means the detected moving image is not a flame. Step 6. Confirm the flame and send alarm. Also sends result to update database. If the color, flickering frequency and centroid location of the flame matches the reference flame features and range, Verifier determines the moving area image as a flame image and generates an alarm signal through the alarm devices. In addition, the analytic results from step 3 to 5 will then proceed to update the database for future references. This flame detection invention utilizes computer programming, based on digitalized video color value changes, to determine if the changes meet the criteria for moving object to be considered as a possible flame. Sounds simple. However, there are many complex programming logic and mechanism with threshold and value ranges that can be improved based on past experience. So we are getting better over time. Give Verifier a try, and you will know how good we are. Contact Verifier customer service at 212-997-2000 or chat with our online staff at www.verifiercctv.com.